Physical Science 20 Introduction and Review, Ionic Nomenclature. This goes along with the IR11 and IR12 assignments. We are going to start by converting names into formulas. This is the same as what we did last class day. Write the positive and negative ion, determine how many of each are needed to make an electronically neutral solid, then write the balanced formula for that salt. Part 1. Write down on your loose leaf, writing ionic formulas. Example 1, copper 1 sulfide. I start by looking up copper to find its symbol, which is Cu. It can be a +1 or a +2. I know it's taking a +1 charge because I have a Roman numeral that tells me copper has the 1 charge. Then I look up sulfide on my negative list. It is S2-. So I have a +1 and a -2. The smallest number that 1 and 2 can both go into is a 2. So to get a +2, I will need 2 coppers. And to get a -2, I need just 1 sulfide. Now I've got a +2 on the front and a -2 on the back. The formula for copper 1 sulfide is then Cu2S. Example 2, copper 2 phosphate. Again, copper is Cu, and I know it's taking the +2 charge because I have a Roman numeral 2 following the copper. I look up phosphate on the negative ion list, that's PO4 3-. The lowest common multiple of 2 and 3 is 6. So to get a +6 on the front, I need 3 coppers. And to get a -6 on the back, I will need 2 phosphates. Remember, phosphate is a complex ion, so it needs brackets if I have more than one of them. Zinc nitrate, hexahydrate. I look up zinc, I see the symbol is Zn and it takes a +2 charge. I then look up nitrate and find that the formula is NO3 with a -1 charge. The smallest number that 2 and 1 can both go into is 2. So to get a +2 charge on the front, I need 1 zinc. To get a -2 charge on the back end, I need 2 nitrates. Now, what about this hexahydrate? Just like you, a salt is hydrated when it has water. On your formula sheet, you can find this box. It says, when we have hydrated compounds, a dot is placed between the ionic formula and the number of waters coordinated around the salt. I don't know how many waters are coordinated around the salt. If I look at name, though, it says the name of the ionic compound is followed by a covalent prefix identifying the number of water molecules, and then followed by the word hydrate. So I have to find a different data table on my formula sheet that is covalent numbering. In the name it says hexahydrate. Well, if I look down the covalent list, hexa means 6. So that means I have 6 waters. So again, a dot is placed between the ionic formula and the number of waters coordinated around the salt, which is 6 waters. Example 4, potassium sulfate. Again, no Roman numeral, so I must get the charge from the periodic table. Potassium, symbol K, takes a +1 charge, so I write K with a +1. I look up sulfate on the common negative ions, that's SO4 2-. Lowest common multiple of 1 and 2 is 2, so to get a +2 on the front, I need 2 Ks, and to get a -2 on the back, I need 1 sulfate. Example 5, tungsten 4-chloride. I look up tungsten on the periodic table and see that the symbol is W. And I know it's taking the +4 charge because the name has a 4 in Roman numerals. I look up chloride on the negative ions list, that's Cl-. The lowest common multiple of 4 and 1 is 4. So to get a +4 on the front end, I need 1 W. To get a -4 on the back end, I need 4 Cls. Example 6, chromium 3 oxalate. I look up chromium on the periodic table to find its symbol. I know it's taking the +3 charge because I have a 3 in Roman numerals in the name. I look up oxalate on the common negative ion list, and that's C2O4 with a 2- charge. I've got a +3 and a -2. The lowest common multiple of 3 and 2 is 6. So I need a +6 on the front end. So to get a +6, I will need 2 chromiums. To get a -6 on the back end, I will need 3 oxalates. Example 7, hydronium phosphide. You can look all over your periodic table, you will not find hydronium, and that's because it's not there. Hydronium is found on a data table titled Common Positive Ions somewhere else on your formula sheet. Make sure you locate where this box is. You will have questions that have ammonium ion and hydronium ion. So hydronium is H3O positive. I look up phosphide on my common negative ions list, and that's P3-. The lowest common charge, with a +1 and a -3, is 3. So to get a +3 on the front end, I will need 3 hydroniums. To get a -3 on the back end, I will need 1 phosphide. Part 2. Write on your loose leaf writing ionic names. If the cation is an element that only has a single charge option, the naming is easy. I look up Ba on the periodic table. It takes a +2 charge, and it's called barium ion. Then I look up Cl on the negative list, and I find Cl-, which is called chloride. So when they come together, they make barium chloride. Cations that take a number of different charges can be tricky. I have CO on the front. I look it up on the periodic table. But is that CO with a +2 or with a +3? And the name is going to be cobalt with some Roman numeral, ion. And we're not sure of what that Roman numeral will be yet. If I look at the back end, I have SO4. If I look that up on the negative list, I see that SO4 takes a -2 charge, and it's called sulfate. I see that I have 3 sulfates. So that means I have 3 -2 charges. And 3 -2 charges add up to a total of -6 on the back end. And we know that the charge on the back end has to equal the charge on the front end. So the charge on the front must be +6. Now, being that there are 2 cobalts there, that +6 charge has to be shared between them. So 6 shared between 2 cobalts is a +3 each, which means I have cobalt 3 ion on the front, and when it comes together with sulfate, it makes cobalt 3 sulfate. Now keep that in mind. If I don't know what the front end charge is, I will have to first determine the back end charge. Example 1. KCl. I look up K on the periodic table. It takes a +1 charge, and it's called potassium ion. I look up Cl on the negative ions list. It has a -1 charge, and it's called chloride. So KCl is called potassium chloride. Example 2, WF3. I look up W on the periodic table. That's tungsten, and it takes a number of different charges. So I'm not sure which Roman numeral I will need. I see I have F on the back, and it takes a -1 charge, and it's called fluoride. Since I have 3 Fs and each has a -1 charge, that means my back end charge equals -3. So that means my front end charge must equal +3. So that means in this case, tungsten is taking a +3 charge. The Roman numeral I need is 3, and the name of WF3 is then tungsten 3 fluoride. Example 3. I start by looking up Fe. it takes a +2 or a +3 charge. And I'm not exactly sure what it's taking this time. So that means I'm not sure which Roman numeral I will need in the name. Well, not yet anyway. So I look up CO3, and I see it takes a -2 charge, and it's called carbonate. When I look at the formula, I see I have 3 carbonates. Each one has a -2 charge. So -2 charge multiplied by the fact there are 3 present gives me a total back end charge of -6. And if I have a -6 charge on the back end, I have to have a +6 charge on the front end. Now there are 2 irons present, so that +6 is being shared between 2 irons, which means they get a +3 each. So I have iron 3 ion on the front, carbonate on the back. When it comes together, it's called iron 3 carbonate. Example 4, ZnSO4. I start by looking up Zn on my periodic table. I see it's zinc. It takes a +2 charge, and we call it zinc ion. I have SO4 on the back end. I look that up on the periodic table. I see it takes a -2 charge, and it's called sulfate. So when it comes together, we call it zinc sulfate. Example 5, I start by looking up aluminum, and I see it takes a +3 charge. An Al3+ is called aluminum ion. I then look up C2O4 on my negative ions list and see it takes a -2 charge, and it's called oxalate. And when it comes together, it forms aluminum oxalate. Example 6, I start by looking up Pb, and I see it can take a +2 or a +4 charge, so I'm not sure what it is taking this time. So that means I don't know which Roman numeral I need in the name. I look up PO4 and see that it takes a -3 charge, and it's called phosphate. Now I have 4 phosphates, each with a -3 charge. So 4 phosphates, each with a -3 charge, gives me a total of -12 on the back end. And if I have a -12 on the back end, I got to have a +12 on the front end. Being that there are 3 PBs, that +12 has to be split evenly 3 ways. So how many times does 3 go into 12? 4 times. So Pb is taking the +4. So it's lead 4 ion. And when lead 4 ion and phosphate come together, it's called lead 4 phosphate. Example 7, SrCl2.2H2O. I look up Sr. I see it can only have a +2 charge, so it's simply called strontium ion. I then look up Cl on my negative list, and I find Cl-, which is called chloride. So SrCl2 is called strontium chloride. Now to deal with the .2H2O at the end of the formula. So I go to the hydrated box, and I see that it says, when I'm naming it, the name of the ionic compound is followed by a covalent prefix identifying the number of water molecules followed by the word hydrate. So I go to my covalent prefixes, and I see that 2 is di. So I use the covalent prefix di and then the word hydrate, meaning water. So 2 waters is called dihydrate. So the name is strontium chloride dihydrate. Now, as you work through the assignment, you will see that on occasion there are multiple cations in a single formula. So it is possible that more than one cation has combined with an anion. When this occurs, the cations are written in the order they appear in the formula. So NaHCO3 would be sodium ion, hydrogen ion, and then the negative carbonate. So we would call it sodium hydrogen carbonate. Although quite frequently the common name for this is sodium bicarbonate. So what is wrong with a name like sodium hydrogen phosphate? Again, I bring this up because it will appear in the assignment, maybe on the test, maybe on the final. So sodium hydrogen phosphate, well, I've got sodium, which takes a +1 charge, hydrogen, which takes a +1 charge, and phosphate, which has a -3 charge. And those don't nicely balance out. In fact, in order for it to balance out, I will either need 2 sodiums and 1 hydrogen to balance off the -3 charge, or 1 sodium and 2 hydrogens to balance off that -3 charge. So again, if it says just sodium hydrogen phosphate, well, when they come together, does it form NaH2PO4 or Na2HPO4? Well, luckily, there's something in the data table for that. If there is more than one cation, and they could combine in more than one way to balance the overall negative charge, a covalent prefix is used to identify how many of the second cation are present. So in the case of NaH2PO4, since hydrogen is the second cation in the formula, it is going to have to carry a covalent prefix. So I would call this sodium dihydrogen phosphate. And if I have Na2HPO4, again, hydrogen is the second cation in the formula, so it's going to carry the covalent prefix for 1 because there's 1 hydrogen. So that would be called sodium monohydrogen phosphate. That's the end of the lesson. You're good to work on that IR 11 and 12 assignment.